In the early years of World War II, the United States government quietly erased over $2 billion from its ledgers and began purchasing massive tracts of empty, isolated land. While the public's attention was fixed squarely on the battlefields of Europe and the Pacific, a hidden domestic industry was being constructed from the ground up, one rivaling the size of the entire American automotive sector. The government hired hundreds of thousands of Americans to build and operate this sprawling infrastructure, yet officially, the project did not exist. While the quantum physics behind the atomic bomb commands the historical focus, the project required an equally massive logistical achievement. The United States managed to build and operate a colossal industrial empire entirely out of sight. The urgency for this massive undertaking arrived in 1939, when theoretical physicists like Albert Einstein warned the U.S. government that Nazi Germany was likely attempting to harness nuclear fission to create an atomic weapon. To counter this threat, scientists had to translate abstract equations into a physical device. But the specific industrial machinery required to safely handle and enrich radioactive materials did not exist anywhere on Earth. Developing that infrastructure from scratch would normally take decades of trial-and-error engineering. To beat the Axis powers, the United States had to compress that timeline into barely 3 years. The government was locked into a blind sprint, committing vast financial and material resources to mass-produce a weapon before they entirely understood the mechanics of how it would detonate. Managing this impossible build fell to Major General Leslie Groves, a highly pragmatic military engineer. Groves selected Robert Oppenheimer, a brilliant theoretical physicist, to lead the scientific design of the weapon. Together, they deployed a rigid, counterintuitive strategy to ensure total secrecy. They would scatter the massive, loud manufacturing plants across distant corners of the country, while isolating the core scientific team in a single, heavily guarded hub. By completely divorcing the physical labor from the intellectual design, they kept the project moving at maximum speed without revealing the final objective to the vast majority of their workforce. A map of the United States shows this divided footprint, establishing isolated nodes in Tennessee, Washington, and New Mexico. In Tennessee, the secret city of Oak Ridge grew to house 75,000 people, dedicated to extracting the unstable isotope uranium-235. Inside these endless, repeating factory structures, the workforce was strictly compartmentalized. Thousands of operators monitored dials and turned valves day after day, explicitly forbidden from knowing what their facility actually produced. Nearly 2,000 miles away in Hanford, Washington, a completely different, massive industrial complex was built with a separate objective: running nuclear reactors to synthesize an entirely new element called plutonium. This severe geographic and operational fragmentation was an intentional security design. If a worker spoke or a shipment went missing, the localized information was useless for identifying the project's final goal. While the factories churned out raw materials across the country, the theoretical minds were locked away on an isolated mesa in Los Alamos, New Mexico, tasked with assembling the final weapon. Their core challenge was designing a precise conventional explosive mechanism capable of rapidly compressing those enriched materials to trigger a runaway nuclear chain reaction. On July 16, 1945, the decentralized logistics and the complex mathematics violently converged in the desert during the Trinity test. The successful detonation of the device proved that the immense financial and industrial gamble had worked, pulling a mathematical concept directly into physical reality. Just weeks later, that physical reality was dropped over the Japanese cities of Hiroshima and Nagasaki. The staggering destructive yield of the atomic bombs forced an abrupt and violent end to the Second World War. Down on the ground, the impact of the scientific breakthrough resulted in absolute devastation, vaporizing infrastructure and tens of thousands of civilians in seconds. The Manhattan Project achieved its immediate objective of ending a global conflict, while simultaneously introducing humanity to the capacity for total, instantaneous self-destruction. The Manhattan Project transformed scientific progress from a series of small-scale laboratory experiments into an industrial-scale operation requiring city-sized facilities and a workforce of 6 figures. This marked the origin of big science, a model where pushing the boundaries of physics and engineering now demanded the full logistical and financial backing of a superpower. By merging vast government funding, strict military oversight, and corporate manufacturing power, the project laid the permanent groundwork for the modern military-industrial complex. The United States successfully hid a sprawling industrial empire to win a global war. But in doing so, it ensured that the rest of the modern world would have to navigate the permanent reality of nuclear annihilation.